Alright, so before we begin, I want to remind you that it's going to be helpful if you have paper and pencil in front of you so you can follow along. And also remember that you can stop and rewind at any point. So if you don't have something to write on and to write with, go ahead and pause and go get them and then come back. All right, so when we're looking at the relationship between polynomials and area, we first have to remember what area means. So area is how many square units cover the whole surface of any given shape. The formula for the area of a rectangle is the length times the width. So area equals length times width, or sometimes we just say A equals L times W. Okay, this is area. Okay, so let's say that I have a rectangle that is 4 units wide and 2 units tall. So going this direction, it's 4 units, and going this direction, it's 2 units. So altogether, we have 8 units that make up this rectangle. So the shortcut, instead of drawing it all out and figuring and counting, is we could say that the area equals 4 times 2. So then the area equals 8 units squared. Square units meaning each one of these units is in fact a square. So if it's inches, it's a square inch, or a 1 inch by 1 inch square. Okay, so sometimes we don't have it quite so neat and tidy. Sometimes it might look like this: x and x plus 2. We don't know how long this side is or how long this side is, but we know that this side is always going to be 2 units longer than this side. So we can say that the area equals x times x plus 2. Now if you think about this, if this is x and this is 2, and this is x, we can kind of see how that works. So here's our dimensions, and then when we distribute, we get area equals x squared plus 2x. Well, thinking about this, the dimensions of this part right here are x times x, which is x squared, and the dimensions of this piece right here is 2 by x. This is 2 and this is x, so this is 2x. So we have a square with the area of x squared, plus we have a rectangle with the area of 2x. So I really like this model because it shows very clearly visually how we get the factored form by looking at the outer dimensions, and how we get the standard form by looking at the sum of the pieces. All right, let's do another example. Let's say we have x plus 3 and this is x plus 4. So here we have, this is x, this is 3, this is x, and this is 4. So our area equals x plus 4 times x plus 3, or you could write it x plus 3 times x plus 4. It doesn't matter the order of these two. right? Just like we could tip this sideways and it would still be the same square. And I am off the screen. There we go. Okay. So then, if I distribute this, just looking back at my picture, right here, I'm going to rewrite it over here because this is kind of a mess. Oops. I have x, 4, 3. So x by x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. So this, in standard form, we can see the overall dimensions. X plus 4 by x plus 3 are the outer dimensions. Here inside I can see that I have an x squared plus 4x plus 3x is 7x plus 12. Okay.